Without further ado, the outro keynote. Where's Khawaja? Our Valky's official Chief Marketing Officer and meme creator extraordinaire. Come on up. Let's give a round of applause for Khawaja and Madelyn.
To be clear, a lot of the memes get created by Hannah and Alan at Memento. I just take credit for their work.
I mean, that's what, that's what the C-suite is supposed to do, is delegate and then take credit for other people's work.
So Madelyn created this nice ChatGPT generated image of me and labeled me as the CMO. And I have to set the record straight. My friends call me CMO anytime they want to really question my engineering prowess. And it's a way to tease me and to put me in my place because I'm a manager now, so I can't be an engineer apparently.
So the only reason I did that is the PR representative we have for the Linux Foundation. Her name's Grace Lucier. She's a wonderful person. I asked her once if I was the best marketing engineer she's ever met. And she's like, does Khawaja count? And she's like, second best.
All right, well, that's very helpful. Well, we know that we are between you and the evening refreshment, so we're going to try to squeeze in as many pieces of learnings as we can, as quickly as we can. So we're going to keep this dense.
We're keeping it very dense, very short,
Yep.
very quick, just like Valky.
Just like Valky. So let's see how much learnings we can squeeze into one. So what we promised here was to share some of the bruises that we have earned and lessons that we have learned on our way in building hardcore distributed systems. And honestly, the way we know that we've done a lot of work here is we have seen a lot of outages and we've made some mistakes. Madelyn's made a lot of mistakes.
I've made so many mistakes.
So the first one that I want to talk about is why the definition of availability matters and why obsessing over definitions matters so much. So a long time ago, I used to work on this project called DynamoDB. Some people have heard of it. And we were very, very proud of our availability. And this particular year, we had done extraordinarily well on our availability. So we showed up to our yearly planning meeting with internal stakeholders. And we very proudly boasted that Dynamo had met its availability SLO for the entire year. And while we were there boasting about that, we weren't really boasting. It just our document just said that, hey, we are proud that we met this. A leader from EBS stood up and said, well, you might think you were available, but we dealt with your hiccups all year long. And I remember several incidents where we had stuck volumes because of your hiccups. And this was a very interesting moment where we said, wait a minute. This is like, we're being called out here. This could get very, very nasty in a corporate world. But here, the intent of the leader was not to make us look bad. It was just a reflection that, hey, you think you're available, but based on what metric? And the metric that we were using to declare our availability was fleet-wide averages. So Dynamo is a distributed system, lots of partitions, and we said, okay, well, across the fleet, our error rate was less than 0.1% for most of the year, and we met the SLO. And it turns out that when you have a very, very large fleet with hundreds of thousands of partitions, you can have one partition that is having a 100% outage, and your fleet-wide average just masks that. And for a single customer with many partitions, a very large table even, if one partition is messed up, their entire workflow can be screwed up. And this was a moment of reflection for us as we leaned in and we literally stopped the planning meeting and we went into this discussion about, well, what should our definition of availability be? And we walked out of there with a pretty good definition of availability. We said we're going to start measuring availability on a table basis instead of fleet-wide partition basis. But the lessons here are threefold. The first one, you got to be vocally self-critical. In the early days of Amazon, there used to be a leadership principle called vocal self-criticism. It got taken out. I don't know why. But it literally, I kid you not, on the Amazon.com website, this leadership principle said, we don't pretend that our body odor smells of perfume, which is pretty apt for, a really good way to describe what vocal self-criticism means. And at the moment you get defensive that, hey, you're being called out, that's when you've lost touch with your customers, because it's easy to say, hey, we'll get back to you, or like, let's talk about the other plans that we have and so forth. But being able to recognize that you are not perfect and that perfection is too heavy a barrier is crucial in these types of situations. The second lesson was your metrics have to be reflective of your customer experience. And if your metrics are not reflecting of your customer experience, you may be celebrating, prematurely on the experience that you're delivering. So next time you're facing, this definition problem of like, well, how do you actually measure availability? Just make sure that you're working backwards from, does your metric capture the actual customer experience? And if it doesn't, then you're going to keep improving a thing that doesn't impact customers. And while that might be cute, it doesn't really help customers, and it won't really grow your business. And when this happens, like this Dynamo experience might not be, something that you might have seen in your careers, but like I suspect people here, does anybody care about durability? No? Oh yeah, I guess we're all caching people, so maybe not.
Caches can be durable.
They can be durable, but not as durable as Dynamo.
They can be more durable than Dynamo.
People really care about durability, and oftentimes I meet customers that want to go multi-region to increase their durability. And sometimes it's for compliance, but sometimes it's to increase their durability. And the metric that they're working on is this binary metric of am I multi-region or not. And the metric they should really be working on is, what is my recovery time objective? What is my recovery point objective? And it's so easy to get distracted by the binary. And in some cases, it makes sense. It's because you have regulation or whatever. But like, it is really, really important, because as much as regulators are important to appease, the customer experience is what really matters at the end of the day. And being in touch with the right metric goes a long way.
Yes, that's very true. The customer experience is really what you should be optimizing for, and really what you should be caring about. One question that I hear a lot is, should we be adding a cache to our system? And a lot of people think, oh, that makes it fast, which must inherently be better. But sometimes it makes your system less stable, and it makes it less predictable. And as we heard Jacob talk about earlier today, it also adds different modes of operation. One thing I talk a lot about is like the metastability that caches tend to have. So caches typically improve the performance of the system up until a certain point. And once you've crossed over that threshold, the system is no longer stable and sort of spirals out into destruction. So, we've been talking a lot about 3AM pages. So I want to tell a story of a page that I had to deal with kind of as an operator inside Amazon Elasticache, the managed caching service inside AWS. And we were working with a customer who was basically preparing for an e-commerce event. And their caching architecture on its face looked very good, right? So they served almost all of the read requests from the cache. And the way it worked was that all of the writes went to the primaries, and they only read from the replicas because they wanted to protect the primaries as much as possible. So they would try to read data from the replica, and if that had a cache miss, they'd then put from the primary, and then they would retry the read from the replicas. And so typically, the latency between primaries and replicas in Valky is very small, right? Order of like a millisecond. So that by the time you got the request back from the primary and you requested from the replica, you would get the request back almost immediately. And so when their event started, they could basically flush the cache, and then everyone would get updated all at once, because all of the cache misses would happen, all the data would get hydrated, so they'd see a one-time spike, everything would stabilize, and everything would be fine. And so this specific customer had done this multiple times, many years over years. The events had grown, everything was fine. Until one year, it wasn't fine. So one year, all of a sudden, the replicas were never getting updated. They were staying stale, and all of the customers, their end customers, were seeing was 500s because none of the data was loading. They kind of freaked out, and it took about an hour for the customer end user load to die down enough that all of a sudden the replicas got updated and everything was fine again. And sort of in a postmortem, they're like, hey, what happened? And what they found out was they had actually moved from a monolithic architecture to a microservice architecture. And so they dramatically increased the number of clients that were connecting all at once to the system. And so like connection storms are a well understood problem in caching space, but this actually was something a little bit more nuanced. So what they actually had was a request storm against the primaries. So they sent so much traffic to the primaries that they overloaded the replication output buffers, which is a mechanism built into Valky to protect the memory usage on the primary. And so all of the replicas got disconnected. And so all of a sudden they had this huge write rate to the primaries, and none of the replicas were getting the updates. And so all subsequent read requests were going to replicas that didn't have the updated data. And the system never stabilized. It was permanently in this unstable state and was never able to recover. So, at Amazon, we have this tool during COEs called like the 5 whys. And so kind of if we break that down, we're like, okay, what happened? Okay, we weren't able to serve any traffic because the read replicas were out of date. And why were they out of date? Because the replication links were broken. Why were the replication links broken? Is because we sent too much traffic to the primaries that it overcame the buffers. And why did we do that? Because we suddenly increased the number of connections to the system. And so you can kind of break down all 4 of those, and like you could have mitigated all of those, right? One of them is they should have tested with this increased load. They basically made an architectural change and then never verified that this architectural change worked. They also never really thought about, what happens in failure modes? What happens if these replication links break? They can break for other reasons. They could be networking issues. The replica might be delayed for some other reason. And so kind of, in addition to what Khawaja was saying, what's really important is to make sure you have that engineering excellence to understand when you're making architectural changes, that you're testing them. You understand the failure modes that you might encounter, and that you're testing them appropriately.
Understanding the dimensionality of your systems and the underlying dependencies is very, very crucial. And by dimensionality, in caches, typically, people think, well, do I have enough CPU? Like, how many TPS can I handle? And do I have enough memory? And that often ends up being the end of that conversation about, is my cache sufficiently scaled? I mean, even if you go for auto-scaling dimensions, those are, I think, still the 2 dimensions that, am I filling up on memory and do I have enough CPU?
And network in and out is typically the other 2.
That's right. So I know you know this. But networking is often the forgotten child where people end up overwhelming the network. And that can happen in multiple ways. You can saturate the network pipe, or you can start creating a lot of connections. And connections are this really underappreciated aspect of, I know Madelyn really understands the impact of connection storms. But in my travels, I see most customers actually haven't appreciated the impact of connections until they have been really bitten hard by them.
They've been paged at 3 a.m. for them.
They have been through that rite of passage. And connections are pretty interesting because we had an issue in Dynamo where, and I think Ankita and Kenny who are in the room, they were on the team at the time, so they may remember this. Dynamo at the time used this load balancing mechanism called least connections. And all that means is when I have a request that comes in a load balancer, the load balancer is keeping track of how many active requests are happening across each of the request routers, which is the front end fleet. And I'm just going to route the request to the request router that has the least number of active requests. This makes sense. Least cons is a very popular load balancing algorithm. The way we do deployments is very clever. We do one boxing. We do, and then we go from one box to an AZ and then multi-AZ and so forth. One day, a request router woke up without a configuration file. And what that meant was it had to send 500s when a request came in because it didn't know how to find, the storage nodes and so forth. The problem was that to say that, hey, I don't know what the hell is going on, it's very fast. And if you compare that to calling storage node across AZs and so forth, is a multiple orders of magnitude faster to say, I don't know what the hell is going on. And so this least const single box shows up and like within micros, it's like, nope, I don't know. And if you look at this, mathematically, what happens is, well, guess where all the requests went? To this single box that was the least busiest because it was handling the request the fastest. So we literally created, well, not literally, we figuratively created what's analogous to a black hole. And we realized that this least cons algorithm can be pretty dangerous in ways that we never appreciated. And there's a problem with failing too fast. I think at the time we ended up adding like a slight delay so that our errors are slightly slower to emulate what a regular request looks like. But paying attention to dimensionality is really, really crucial. And being able to handle the number of connections is also very important. This is why proxies are so cool. I know Madelyn is not necessarily the biggest fan of proxies, but we'll convert her. Proxies help absorb connections. And this is why, because if you have a Kubernetes cluster for some reason, you might have thousands of pods that get rescheduled, and each of those thousands of pods will come in and make their own connection pools. Each of them are trying to make 20 connections to every partition, every replica of the partition. That is a connection storm. And proxies really help with that, I think.
Says the individual trying to sell you a product that's a proxy.
There's lots of
This is like Anthropic being like, you should use more AI.
there's alternatives. You can use Envoy if you.
No, don't use Envoy.
Thank you. You said it, not me. But connections are really important to appreciate. And connections we've seen connections cause issues where there weren't enough connections. So we had an issue with one of our customers where the Postgres wasn't responding as fast as they thought it should, and they had scaled it up to the largest type, this instance type that Aurora can support. And the issue just ended up being that their proxy had too few connections to the backend. So things were just backlogging. So again, understanding the dimensionality, understanding what is actually happening at the different layers and how your system scales for those. We had a near outage when we were supporting Fox for the Super Bowl where we were trying to support millions or tens of millions of concurrent connections. And we were very proud. We vetted that we can support tens of millions of concurrent connections. And an hour before the event is when we realized, oh, shit, what happens when all of those connections start getting established at the same time? So it's not even just the number of connections you can support, it's also the number of SSL handshakes you can support at a time. And how do you isolate those, the cores that are handling the TLS handshake so that new connection storms coming in aren't screwing up the rest of the data plane? So again, like you constantly get surprised as you're building systems. And if you're trying to build a system that you think is never going to fail, well, you're wrong. That's why the vocal self-criticism matters. And just being ready to appreciate when a lesson like this shows up to say, okay, how do I go improve my system? And how do I improve my setup to be able to handle the next outage that I haven't thought about?
Yeah. I'll end with maybe one more story. So, in this whole vein of connection storms, we at one point had a customer who, is an Amazon customer that, maybe runs like a box that you can talk to. They were having a very similar problem with connection storms. And what they were seeing, every time they did scaling operations, the way Valkey operates is, especially in Amazon Elasticache, is we spun up net new nodes. So if you had a 320 node cluster, we would spin up another 320 nodes on the new version, new configuration, and then migrate over. And so during that migration, there's a lot of constant topology refreshes happening because the topology is constantly changing. We're adding new nodes, they're getting updated, there's moved redirects, and clients are constantly recalling the same API, which is called cluster slots, which is the command that basically says, hey, what's the topology of the cluster? And we had this customer constantly complain to us being like, hey, this is slow. And, for a while we were just like, well, this is just how the behavior works. But one of the great things about open source is we actually, said, well, we can actually make this better. So one of the features we built early on in, Valkey was the ability to cache the responses for the Valkey responses. And so, this vocal self-criticality really works well in open source and community-driven stuff, because if you find an issue, you can go and say, hey, this is bad. We can make it better. And no one's trying to sell you anything. We're all in this together, and we'll make it better together. So I like that.
When you see problems inside of Valkey, just know that we don't believe Valkey is perfect by any means. We want issues. We want to see where Valkey is not working well and the capabilities that it needs to do better.
Yeah, we're all in this together.
Thank you, everybody, for coming and for making this event amazing. One thing we ask of you is to keep the momentum going, engage with posts that you see, write a blog if you can. Would blogs count as a commit?
They do. You do get, well, not in this. This is so beautiful.
Oh, because it's a fireside chat.
It's a fireside chat. Yeah, it's a fireside chat. And this is it's like Washington Mountains, right? Isn't this beautiful? I was originally trying to find a Minnesota thing because I'm from Minnesota with a lake, but this is so much prettier. This is why I moved from Minnesota to Washington. Anyways, yes, blogs do count. You get points for those. You can get coins for writing blogs. It's just a PR process. If anyone wants to write something, we love to get new voices onto the websites. We love to hear your stories. Even if you think the number of people have come to me and be like, I don't do anything interesting with caching, and then they tell me that just the stupidest things they do with caching is just like wonderful. I want to hear about all the crazy things you do that you maybe shouldn't be doing, but I love that you do it anyways. So, thank you. I appreciate all of you.